Welcome student in today's session. In this session, we will study few more examples based on probabilities. I hope you have done the assignments which was given to you on the day 1. For A blood group, we have total 12 students. For B blood group, we have 20. For AB, we have 10. And for O, we have 18. Alright. Now, what is your definition for probability? What is the formula for probability? Which is number of elements in one event divided by total number in the sample space. Alright, now what is the sample space over here? Sample space is the total number of students that we have. How many students that we have? We have total 60 students. So our sample space would be 60. Yes. Now, for the first question, we have to find out probability that the selected student has blood group O. Let's see from the table how many students do we have for blood group O. For blood group O, if you observe, we have total 18 students. Yes. So, the probability of students' blood group being O is equal to the formula that we have is number of students having the blood group O divided by the total number of students. For blood group O, we have total 18 students divided by the total number of students that we have is 60. Yes, after reducing it, we get this as, so that is 3 by 10. The probability is 3 by 10. You can also write it down as 0.3. If you want, you can keep it till 3 by 10. You can keep the fraction as well, or you can divide it and write it in the decimal also. That is up to you. Now, for the next question, we have to find out probability that the student does not have the blood group O. Alright. The total number of students, that is, this is our sample space, which is 60 students. We have to find out probability of number of students not having the blood group O. Alright, there are total how many sections? A, AB, and then B. And last is O. Bifurcated by 4 types of blood groups. And we have number of students for each of them. We want the number of students not having the blood group O. If we want to select a student who don't have blood group O, which means they can either have the blood group A or AB or B. Out of these 3, that student could be any one of blood group type. Only thing is that we don't want the blood group O. So that would be equal to, if from the total number of students is 60, if from the total number, if we subtract the number of students having the blood group O, we can get the remaining students who have these 3 blood groups. Yes, that is finding complement of the set. Finding complement of the set. Yes, so complement of the set would be number of students not having blood group O equal to total number of students, which is 60 for, minus number of students having the blood group O. Just now in the last example, we have seen that it is 18. So 60 minus 18, it would give me 42. Now we have to find out probability for these 42. Probability of students. 42 number of students there are who don't have the blood group A, and they have the other blood groups which can be either A, AB or B. So the probability of students not having blood group O is equal to number of students not having blood group O divided by the total number of students. We have 42 divided by the total number is 60. After reducing it, we get this as 7 by 10. 7 by 10. You can write it down as 0.7 also, or keep it till 7 by 10. Alright, I hope the last example is clear to you all. Now we'll move further to this example. In a test of 100 marks, the marks scored by the students of a class are given below. Now, there was a test taken of 100 marks total, and we haven't given the number of students, total number of students over here. Now, for this 100 marks, we have to find out if you see the table that we have two rows into it. The first is interval of marks, and then we have number of students. Interval of marks as in we have total 0 to 10, 10 to 11, which means the number of students who have scored marks between 0 to 10. It could be 1, 2, 3, 4, 5, 6, 7, 8, 9 to 10. Yes, number of students. And then we have number of students, which means there are only 2 students who have scored marks between 0 to 10. We don't know exactly the marks that they have obtained. We just know that the range of their marks. Similarly, we have 3 over here. Number of students 3 for 11 to 20. For 21 to 30, we have 6 students, so on and so forth. Alright. Now, a student of the class is selected at random. Find the probability that the student has scored less than 30, at least 60, and not less than 81. Alright. Let's find out how many total number of students do we have, because that would give us our sample space. How will we find out the total number of students? Here we have been given the count for number of students, right? For each interval of marks. For example, 0 to 10, I have 2 students. Then for 11 to 20, 3 students. Alright, all the students have given the exam, and this is the score that they have got. So from this number of students, from this table, we can get the count for the number of students by adding all of them together. And that would be equal to 80. If you see here, total number of students are 80. So that is our sample space. Alright, what is the first probability to be found out? Less than 30. We have to find out the students who have scored less than 30. For less than 30, which means those students have marks less than 30. It could start from 0 to 30. So if you look here, the interval of marks, first we have 0 to 10. So this we can consider for less than 30. Similarly, 11 to 20 and 21 to 30. They have asked about less than 30. Alright, so how many number of students do we have? 2, 3 and 6. So that is 2 plus 3 plus 6, which is equal to 11. There are total 11 students who have scored less than 30 marks. Now let's find out the probability of all of them. So the probability of students scoring less than 30 is equal to number of students scoring less than 30 divided by the total number of students. Just now we have seen the number of students scoring less than 30 is 11 divided by the total number of students. From the table we have 80. Alright. Similarly, number of students scoring at least 60. at least 60 marks. Now what do we mean by at least 60? At least 60 is 60 or greater than, equal to. Alright, at least 60 is 60 or greater than 60. 60 or more than 60 marks, which means they will belong for the table 61 to 70, then 70, 71 to 80, so on and so forth. And last we have till 90, so that's it. So if we see from the table that the number of students who have scored more than or equal to 60, see here, that is 12, 5 and 4, which is equal to 21. So the probability of the student scoring at least 60 marks is equal to number of students scoring at least 60 divided by the total number, which is 21 by 80. Now let's look at the third example. The third example is asking us to find the probability of number of students scoring not less than 81. Now what do we mean by not less than 81? We don't want those students who have scored less than 81, which means we want to find out those students only who have marks greater than 81, 81 above. So from the table, if you observe, for 81 above, we have only one column, which is the last column, 81 to 90. And in that column, the total number of students that we have is 4. So the number of students scoring more than or equal to 81 would be 4. So the probability of the student scoring not less than 81, let's substitute everything into the formula. Number of students scoring not less than 81 divided by the total number of students, which is 4 by 80 reduces to 1 by 20. All right. Let's take this third example. A box contains 90 discs numbered 1 to 90. In a box, there are total 90 discs. You must have seen discs. On each disc, there are numbers given to them, ranging from 1 to 90. Alright, each of them have numbers labeled on them. One disc is drawn. Our experiment is one disc drawn at random from the box. Find the probability that it bears a two-digit number, a perfect square, multiple of 5, and a number divisible by 3. Now let's look into it one by one. First of all, let us find out the sample space for this experiment. What is an experiment? One disc is drawn at random from the box, and in that box we have total 90 discs. So we have total 90 possibilities of taking the disc out. That is why our sample space here would be all the discs numbered from 1 to 20, 1 to 90. And that is why the n of s would be equal to 90 for us. Total number of possible outcomes 90, since the discs are numbered from 1 to 90. Alright, sure. Now let's see the first question that we have. What is the probability that it bears a two-digit number? Which means that the disk we are taking out, on that disk we want a number which is a two-digit number only. We don't want a single digit number from 1 to 90. Now, how many numbers would be there which are single digit from 1 to 90? Obviously the first 9, which is 1, 2, 3, 4, so on and so forth till 9. After that, we have two-digit number, that is 10, 11, 12, 13. We have two-digit numbers. So total there are 9 numbers which are single-digit numbers. Alright, so how will we find out two-digit number? Total number is what? 90 minus the single digit number, because remaining whatever, only these 9 numbers are single digit. Remaining after them from 10, we have all two digits number. That is why from the total number 90, we are subtracting the single digit number. So remaining numbers is 81. All 81 numbers are two digit numbers. Alright. So therefore, probability that two-digit number occurs is equal to number of two-digit numbers from 1 to 10 divided by the total number of possible outcomes, which is 81 by 90. After reducing, we get that as 9 by 10. You can write it down as 0.9 also, or keep it till 9 by 10. Let's take a look at the second question into this one, which is a perfect square. Now, what is first of all a perfect square? Perfect square is any number which is a square of any another number. All right. What is a perfect square? Any number which is a square of any another number. For example, if I am taking 1, is 1 square of any another number? Yes, 1 is a square of 1 itself, right? So 1 is a perfect square. Yes, is 2 a perfect square? What we have to check is 2 square of any another number. We don't have to check the square of 2. We don't have to check the square of 2. No, we have to check whether 2 is square of any another number or not. We know 2 is not square of any another number. So 2 is not a perfect square. Similarly, is 3 a perfect square? Is 3 a square of any another number? No, 3 is not square of any another number. So 3 is also not a perfect square. Another is 4. Is 4 square of any another number? Yes. 2. 4 is a square of 2. If I take 2 square, that is equal to 4. So 4 is a perfect square. If we check for 5, 5 is also not a square of any another number. So that is also not a perfect square. So perfect square would be what? Let's take the squares of numbers from 1, 2, 3, 4. For 1, we have 1. Then next 2 square is 4. Then we have 3 square as 9. 4 square as 16. 5 square as 25. 6 square as 36. 7 square as 39. 8 square as 64. 9 square as 81. Then 10 square is 100. Yes, but in our sample space, we have numbers from 1 to 90 only. 100 does not come in this range, so we don't take this one. We do want only those numbers which are square of any another numbers. Until 81 only we have that last number. After that, it is out of our range, out of our sample space. So if we count this perfect square, we have total 9 perfect square. So to find out the probability that a perfect square occurs on that disk, that perfect square should occur, which is number of perfect square divided by total number of possible outcomes, that is 9 by 90, which is 1 by 10, can also be written as 0.1. I hope the perfect square definition is clear with you all. Now the third that we have is a multiple of 5. We have to find out those numbers which are multiple of 5 between 1 to 90 only. Alright, multiple of 5 as in how to find out which numbers are multiple of 5. First way is, let's take the table of 5. 5 into 1 we get 5. Then we have 5 into 2 as 10. 5 into 3 as 15. That is what multiple of 5 are, right? So up till 50. And after that, we know that if we check the table of 5, each of the number has difference of 5, right? So go on adding 5, 5 with each of them and stop where our range ends, that is 90. So that is up to 55, 60, 65, 70 till 90. These are our multiples of 5. How many of them do we have? Total 18. Yes, so the probability would be number of multiple of 5 divided by the total number of possible outcomes, which is 18 by 90, that is equal to 1 by 5. Let's take this fourth example, number which is divisible by 3. Now what we want to find out, we want to find that the number is divisible by 3. The disk that we are picking out randomly, on that disk, whatever the number appears, that number has to be divisible by, we don't know, it is unknown. That number has to be divisible by 3 itself. Alright. So let's find out how many numbers do we have. For finding out divisible by 3, here also what we can do is, we can take those numbers which are multiples of 3. Right? If we check the table of 3, in that all of the numbers would be obviously divisible by 3. So 3, 6, 9, 12, 15, 18, 21, 24, so on till last is 30. And we know that when we are finding the table, the difference between each of the numbers is 3. So go on adding 3, then we have till 90. These numbers are divisible by 3. So there are total 30 numbers. So the probability would be 30 divided by 90 after reducing, which is 1 by 3.